So now the topic is quality control test for the parenteral dosage forms. See here the parenteral dosage form. What are the necessity requirement for the parenteral dosage form is the parenteral dosage form it must be sterile. Next one is it must be free from the pyrogen. Next one is it must be free from the particulate matter, nothing but any foreign particle. Next, the parenteral solution must be clear. Next one is the parenteral solution should be stable and it must be stable. Next, should be isotonic. The parenteral preparation it should be isotonic. So these are the necessary properties of the parenteral dosage forms. See, the first one is leakage test. The first one is leakage test. This leakage test only performed for the ampoules. See, we people already know that is unit dose and multi-dose. Under the unit dose, ampoules will come. See here, take one container. That container can be filled with 1% methylene blue solution. Okay. After that, we need to place the ampoules within the methylene blue solution. Then from the externally, we need to apply the negative pressure. Externally, we need to apply the negative pressure. What is that means? 27 mm of Hg. Negative pressure we need to apply. See why we need to apply this negative pressure means if we people have applied negative pressure, then the methylene blue will enter into the defective sealing ampoules. The methylene blue solution can be entered into the ampoules with defective sealing. So for that purpose, we need to apply the negative pressure. Then after this applying this negative pressure, then this vacuum can be we need to remove. The vacuum can be we need to remove. After that, the ampoules we need to take from the container. Then that ampoules, particular ampoules we need to wash. That particular ampoules we need to wash. Okay, after washing, then we need to observe if is there any presence of dye within the ampoule. If there is a presence of dye, methylene blue, then it simply indicates the ampoules having defective sealing. So this is the leakage test only for ampoules. Next one is see vials and bottles. Vials and bottles we cannot perform the leakage test because these vials and bottles having the rubber closure. See this rubber is a not a rigid one, hence we cannot perform the leakage test. So vials and bottles can be can be performed two kinds of test. One is water hammer test. See another one is spark probe test. See in the water hammer test, take one water bottle. See, take one bottle. The base of that particular bottle can be strike with the heel of the hand. The base of the bottle can be strike with the heel of hand. If there is a production of water hammer sound, if there is a production of water hammer sound, then we can detect there is a presence of vacuum. See, actually, while preparing these bottles, we need to remove the vacuum. So whether the vacuum is present in that particular bottles or not can be confirmed by water hammer test or spark probe test. If there is a production of water hammer sound, then it is we can confirm that vacuum is present within this bottle. So leakage test that can be for the ampoules can be performed by dry bath method or vacuum pull method. What is the pressure means 70 mm of Hg. Next, for the vials, we can perform water hammer test and spark test. What is the vacuum we have applied means 27 mm of Hg. Second one is spark probe test. See in the spark probe test how we are performing means see initially this is a container that is filled with liquid. This is a filled with nitrogen because we need to remove the air. That vacuum can be removed from this container. Then that empty space or head space is occupied with the nitrogen. Then spark tester we need to apply. Outside of the container, we need to keep the spark tester like that. After keeping, then that spark tester can be moved from this down bottom to the upside, means from the liquid layer into the airspace. Now we have applied. Now we have applied the spark tester in the empty space. Now in the empty space, because of the presence of nitrogen, there is a production of blue colored spark. See, this is a blue colored spark. If it is contains the headspace, it contains nitrogen, then blue colored spark can be produced. See how it is blue colored spark is produced means, see nitrogen in the ground state, it will absorb the light energy. After absorbing the light energy, the nitrogen will get excited. Once the nitrogen is get excited, after that it will need to comes to the ground state. When the nitrogen will come to the ground state, then it will releases one kind of light energy that is blue color in nature. So that can be confirmed. Means the presence of vacuum can be determined by spark probe test in case of bottles. Next one is clarity test. See in the clarity test, we need to observe in the with naked eye, we need to observe the presence or absence of any particulate matter in the given parental preparation. See how much means particle size, how much particle size our naked eye can observe means only 50 micrometer. See the the parenteral preparations which are given by the IV intravenous route, it should be free from the particulate matter. So that is a major concern here. And then this is a clarity test. See, this is a clarity test. So it will contains black background and white background. See, this black background for what purpose we need to use means for detecting the white colored particles. This white background can be used to detect the black colored particles. Just we need to keep the ampoules here. Ampoules we need to keep, and then we need to detect if is there any presence of particulate matter. Then what is the limit for that particulate matter limit for that parental dosage form means if the particle size in case of small volume parentals, if the particle size is greater than 10 micrometer, by light obstruction method only 1000 particles per container can be allowed. The same greater than 10 micrometer particles in case of microscopic method, 3000 particles per container can be allowed. If the particle size is greater than 25 micrometer, in case of light obstruction method, only 600 particles can be allowed. But in case of microscopy method, only 300 particles can be allowed. That is per container. Next one is in case of large volume parentals, if the particle size is greater than 10 micrometer, in light obstruction method, only 25 particles per ml. But in case of microscopic method, 12 particles per ml. Greater than 25 micrometer particle size, in case of light obstruction method, only 3 particles per ml can be allowed. Only 2 particles per ml can be allowed in case of microscopic method. So this is about the clarity test. The next one is sterility test. Sterility nothing but the presence of viable or sterility nothing but complete absence of viable microorganisms. Complete absence. Even one microorganism also cannot be allowed. Hence, complete absence of viable microorganism we can call it as sterility. See how we can perform sterility nothing but see this is a parental dosage form. So this is a parental dosage form. To the parental dosage form, we need to add the nutrient media or water. Why we need to add nutrient media means for the growth of microorganism. After that, the parental formulation can be filtered through the filters, through the membrane filter. The parental formulation can be filtered through membrane filtration. Once the filtration has completed, the membrane can be divided into two halves. One of the portion, half of the portion can be added to the soybean casein digest media. Okay. For what purpose we are adding means soybean casein digest media that can promote the aerobic and fungal growth, and that can be autoclaved for the 121 degrees centigrade for the 20 minutes. This is soybean casein digest media. Another half is there. See, another half of the portion that can be added to the fluid thioglycolate media, that is held at 30 to 35 degrees centigrade. See, for what purpose we are adding here means for the growth of anaerobic growth. For the growth of anaerobic microorganism, we can use the fluid thioglycolate media. Next one is pyrogen test. Next one is pyrogen test. See, the pyrogen that can elicit the immune response means that will activate our immune system. By activating our immune system, that will produces the fever and chillness. Any substance that will activate our immune system and produces fever and chill, we can call it a pyrogen. See, the pyrogen can be performed in the two methods. One is rabbit test, that is in vivo method. Another one is lol test. See, this rabbit test is in vivo. Nothing but we need to perform within the animal. See, rabbit, we have used to test animals because rabbit is highly sensitive towards the pyrogen. Next one is the test sample injected in the test sample can be injected into the marginal ear vein of the rabbit. In the marginal ear vein, we can inject the test solution. Next, we need to perform the preliminary test. Why we need to perform the preliminary test means for the selection of a rabbit. That preliminary test also we can call it a sham test. Next one is if any animal that is showing the temperature variation of 0.6 degrees centigrade, see that cannot be used in mine test. If any animal in the preliminary test or in the sham test, it is showing 0.6 degree elevation of body temperature, then those rabbits cannot be used in main test. So what is the major disadvantage of this rabbit test is the rabbit cannot differentiate the endotoxins from the imitative pyrogens. Means endotoxins cannot be differentiated from the other pyrogens. See, that is the major disadvantage associated with rabbit test. Okay, initially we need to take the three rabbits, then for each rabbit we need to observe the temperature. If each rabbit is showing 0.6 degrees centigrade, then in the group combination of these three rabbits value it is 1.4%, then the test passes means the given solution is pyrogenic in nature. Then if above test is get failed, if above if above test is get failed, then three we have used in the first test. Now in the second test we need to take the five rabbits. Three plus five total eight rabbits. For the eight rabbits here the for the eight rabbits here for individual rabbits the temperature is 0.6 total means for the total eight rabbits if the temperature variation is 3.7, now the test passes nothing but the given test solution is pyrogenic in nature. So this is about the rabbit test in vivo. Next one is LOL test or bacterial endotoxin test. Also we can call it a Limulus amoebocyte lysate LOL test, that is in vitro test. See that LOL reagent can be obtained from the horseshoe crab, nothing but Limulus polyphemus. See what is the importance of this test means this test only detects the endotoxin that can be derived from the gram negative bacteria. It is a semi-quantitative test. Next one is this test is 5 to 10 times more sensitive than a rabbit test. LOL test is 5 to 10 times more sensitive than a rabbit test. See here, just we have added LOL reagent. That is the blood of horseshoe crab that can be added with the test sample. After adding this After adding the test solution to the LOL reagent, if there is a formation of the gel, if there is a formation of the gel, then it simply indicates the presence of endotoxin. So this is about the test can be used, quality control test can be used for the parenteral dosage forms.